All right. Hello, math fussers. We have moved away from talking about finding the quotient and product or division, multiplication of integer numbers, particularly negative numbers, to combining them, which people can say is addition or subtraction, whatever really works for you. I just like to say combining, but however you see it. Okay. All right. So, looking at some challenges based around combining or adding or subtracting integers, let's take a look at from your packet. Was that page 141? And oh wait, whoa, not that one. I do apologize. Not page 141. I apologize. Page 101. That page. I'll take a look at the page. So we have. Let's take a look at challenge number one, which is 5 minus 12. So there are a number of strategies I'm going to show you that work better or more effectively in different situations. And so that's the reason why I'm going to show you a number of strategies when it comes to combining or adding or subtracting integer numbers. So let's take a look at this challenge we just talked about. That one was 5 minus 12. Now, I'm going to be really honest with you. If you're my students, you're not going to see a lot of this plus negative 12. The reason why is because in algebra, we don't do a lot of the plus the negatives. Well, what do you mean by that, Mr. Let me give you a quick example. Let me change colors here. We don't tend to be like this in algebra. Let's say negative x plus negative x. That doesn't happen a lot in algebra. Okay, unless there's like some negative integer or something in front of it. So that doesn't happen. Even though we're seeing this because you're just starting to algebra to kind of get you over, like, baby steps over to it. We want to go ahead and just move you right into that idea of seeing it as this. All right. And remember we talked about the invisible uno. All right. We talked about variables. The same thing here. Invisible. Resulting answer is going to be negative 2x. That's not important. The resulting simplifying of these of this expression here was really important is that I want you to move away from thinking about plus the negative 12 to just the idea of that 5 positives and 12 negatives, which I like to model this way. We're going to change it from what you just saw there to this. 5 minus 12. Now let me clean it up, make it a little clearer for you. Right. So then it's like, wow, okay, 5 minus 12, but Mr. Heath, that's not normal. You don't see this number being smaller than this number there. So that can make you nervous. I like to separate. Oh, chihuahua. I'm separating the wrong pieces. So I like to separate. I like to think of this as, let me do it this way. I like to think of this as 5 positive and these as 12 negatives. Then that allows me to apply a number of different strategies here I'm about to show you. So the first strategy that we can use here, that we think of these as negative and positives and not like addition and subtraction, is the idea of negative and positive charges. So you'll notice here on the first, for positive 5, I put the little positive charge and negative charge here on the little charted table, but I have 5 positives or positive 5. So 1 positive, 2 positive, 3 positive, 4 positive, 5 positive. You'll notice here my little separation line helped me out that I have 12 negatives. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 12 negatives. Well, let's start doing some canceling out here. 1 positive, 1 negative, nothing. 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 How many negatives do I have left over? I have 1, 2, 3, 4, 5, 6, 7 negatives left over. The resulting answer for this one is going to be negative 7. Okay. Why is it that a negative and positive equals nothing? Let's talk about that. I'm going to erase this here. Actually, I'm going to erase all the stuff up here so we can get more space. Let's show you the reason why. Equals nothing. Okay, so if I have a negative here and a positive here, it equals nothing. Let's show you why. So let's say that you're starting here and you walk forward one space to right here. Okay. So then you went one space forward, but then you decide to go back. Okay, so then you see it this way, but go back to your original space. Well, you can see if you go back to your original space, you didn't move. No movement. There was no movement here. I mean, you moved forward, but then you came back, so you're at zero again. That's why one positive movement and one negative movement will always equal zero. And that's why you've extended out here. One negative and one positive, or one positive, one negative will always equal zero. So that's how we get the answer of -7 there. So that's one strategy that you can apply. We're just using negative and positive charges. And that kind of works, but you can see as the numbers start getting larger, that becomes really hard. So I want to show one strategy you can use for smaller numbers, but I do use it here. So with 12, with -12, and that is the idea of the number line. So let's try this again with, it was 5 minus 12. And notice I put the separation line. So separation line, 5 minus 12. Okay, so what I could do is go to 5 here. So 0, 1, 2, let me put this down, 3, 4, 5. Everyone would agree I went 5. 0, 1, 2, 3, 4, 5. So I went 4 or 5. Well, that takes care of that. But then it says that I got to go back negative. Because remember the rule is if you see a negative number, you go in which direction? To the left. So let's do that from here. So my new 0 point, right here. New 0 point. So now I go, I'm going to go ahead and put this down this way. -1, -2, -3, -4, -5, -6, -7, -8, -9, -10, -11, -12. Hey. And guess where I wind up at? Hey, oops, -7 right there. So notice 0, 1, 2, 3, 4, 5. Okay, then -12. -1, -2, -3, -4, -5, -6, -7, -8, -9, -10, -11, -12. And a line of -7. So the resulting answer is still the same, -7. So that's one strategy. Second strategy you can apply when it comes to combining. All right, so let's talk about another strategy. Strategy number 3 here is combining of negatives and then the addition of subtraction. So this is what I mean by combining of negatives and addition and subtraction as a strategy. So let's say you get something like, let's look at one of your challenges. So one of your challenges, ah, so one of your challenges here it is challenge number 17 at the bottom here. Number 17. Okay, it's -34 minus, what is that, 57 or 27? Okay, so let's take a look at this one using strategy number 3. This is kind of a large number. You may not want to use a number line. You may not want to put a whole bunch of negative positive integers there. So remember, they're going to give it to us originally this way. We don't got to use it that way. We don't have to keep it that way. So we're going to change it, all right? Make it better for us. -34 minus 27. So notice I'm telling myself, or I'm saying -34 minus 27. But here's what I'm really thinking when I say -34 minus 27. I'm thinking 34 negatives, 27 more negatives. I don't know off the top of my head, so I'll go over it. 27, 34. The sum of 7 and 4, well, that's going to be 11. The sum of 5 and 2, that's going to be, excuse me, I just said, the sum of 3 and 2 is going to be 5, plus 1 is going to be 6. So I combine these here. That gives me 61. And remember, they're both negative, so 34 negatives, 27 negatives. I have a total of 61 negatives. So notice the strategy I use, a little throwbacker math, addition, but a little here and now thinking. Negative integers. Okay, 34 negatives, 27 negatives. How many negatives altogether? Hey, 61 negatives. So use a little throwback math to help you also like these new thinking ideas with, okay? So that's your third strategy. Oh, let's talk about the other part of the third strategy as well. Let's say one challenges you have here. Okay, this is kind of hilarious, but we'll do it. You have number, where is it? Number 24. So let's see, number 24. So with number 24, you have negative 16 plus 16. And remember what I said, the idea of just applying addition and subtraction sometimes. So we may have negative 16 plus 16, but we can change that. Remember, we can move these things around the way, these integer numbers the way we feel like. So that kind of throws me off. So I'm going to go back to some throwbacker math that I knew and that you guys all know the difference of 16 and 16. You got it. Or if you want to get super nerdy about integers, 16, negative 16 plus 16, 0. So recognize that we can move these integers around. We have to keep like we used to when we were doing like elementary mathematics, arithmetic. All right, so that is strategy number 3 that you can use. All right, and now let's go ahead and do strategy number 4. Let's pull strategy number 4. So strategy number 4 is subtract keeping the sign of the larger absolute value. All right. What does all that mean? Well, remember we talked about absolute value. What we say absolute value was, absolute value is the distance a number is from 0. Let's just go over that just a little bit on this one here. So we're going to make sure y'all understand that. So, absolute value. Absolute value. We had a conversation about this. We said, what is a distance? A number is from 0. This is what these two lines mean. I kind of joke with you guys and say, hey, man, how far is negative 7 from 0? And actually, that's what absolute value really meaning here is that even though this may be sending us in a leftward direction because it's negative, this may be sending us in a rightward direction on the number line because it's positive. The distance from 0 is still the same for both of these. So absolute value of negative 7, you got it, 7. Absolute value of 7, 7. Why? Because that's the distance there from 0. So we have our absolute values there. Okay, we've had that conversation. So now we are going to apply strategy number 4. So let's take a look at one of your challenges from your packet. Let's see which is a good one to use here. Number 18 is a really great one, I think. Let's take a look at challenge number 18. We have 23 minus 31. Okay, so 23 minus 31. So what we're going to do here is I'm going to apply strategy number 4. I'm going to find the difference of 31 and 23. So let's find that difference. Well, how many sets can we, obviously can't take a set of 3 out of a set of 1 here. So we're going to go ahead and go over there, put that in one's place value. So then I have the difference of 11 and 3, that's going to be 8. Then I have the difference of 2 and 2, that's going to be 0. So I did subtraction just like I normally done back in the day. So I have subtraction, I have 8 there. But here's the interesting thing. It's said to keep the sign of the larger absolute value number here. So if we take a look, let me erase this. Let me erase this. If we take a look here at the two numbers that we're working with, the two integer numbers here, we have 23, absolute value of 23. You got it, 23. Or the distance 23 is from 0, 23. Let's look at the absolute value of 31. Or the distance 31 is from 0. Hey, that's 31. The absolute value of negative 31, 31. Well, we can already see. I'm going to use the less than, greater than sign, put in between. We see that 31 is greater than 23. What sign did 31 have? It had the negative. And therefore, I'm going to go over here, and my resulting answer is going to be negative 8. So that's how that all works out there. I'm sorry I'm kind of putting my face in here and anything like this, but I think it allows you to kind of understand better. I'm kind of poking it in right. So there you have it. There were 4 strategies that we talked about. Rewind and go through them if you were confused about the strategies. Let's talk about where you can apply those strategies. You can apply the strategies definitely on page 101 of your packet. Find some other pages here you can apply them on. That was one. You can apply these strategies on page, what is that, 99 of your packet, page 99 of your packet. Oh, this is an important one here, 113. Let's talk about the stuff on 113, the challenges here, because these are unique challenges. They involve double negatives. So let me go ahead and talk about double negatives. So double negative integer numbers. So let's go to page 113 and look at a few challenges from here where they have double negatives. All right, let's look at the first challenge here, 3 minus 2. What strategy would you use in that one? I will go ahead and use arithmetic. All right, the difference of 3 and 2 is going to be 1. Let's go down. Once again, I have 3 minus 3. I'm going to use arithmetic. Then things change up a little bit here at number 3. Add 3 minus 4. There's a number strategy we talked about that we can use on that one. We can separate in 3 negatives, 3 positives and 4 negatives, and figure out the answer there. But let's go to where things get really interesting. They get really interesting when we get down to number 11. Let's take a look at number 11. Number 11 has 3 minus negative 1. We haven't seen that before. So let's talk about that situation there. So I have 3, what is that? Minus negative 1. Here is the rule and the strategy that you will apply in the situation here. Anytime you have a double negative, it's going to be positive. There's a couple ways you think of it this way. You could think of this as remember our invisible uno. So you could think of this as an even amount of negatives being multiplied. What's your resulting answer there? Positive 1. So that's one way to see it, okay? Another way to see it is that that's just the rule. Double negatives equals positive in that situation, okay? Double negatives equals positive. We can show you the number line. I'll give you another explanation. So we'll go here on the number line. Let's say I'm at negative 1. Let's say I'm at 1, negative 2, 2. I go to from 0 to negative 1. What's the opposite? Positive 1. Gives me 0 there. So, different explanations for it, but in a sense, all you really want to do is know that when you see 2 negatives bunched up this way with the brackets and this outside there, it's going to equal positive. All right. So that was the idea. So let's go ahead and simplify based on either one of those strategies that you like to think of or keep in your head or use, whatever. All right. So we'll go here. I have 3 plus 1, and your answer is going to be, what's that, 4. Resulting answer, 4. Let's look at another double negative 1. Let's go to double negative. Oh, let's go to number 39 in your paper. So number 39, kind of big numbers, okay? So 39 has negative 20 minus negative 45. If we remember this, the rules, sort of like the algorithm, or what you want to call it there, we see double negatives, instantly becomes positive. And I talked about the thinking behind it. We're just going to go ahead and apply the strategy without worrying about the conceptualization. So notice here, now I have negative 20 plus 45. I can apply another strategy here. I could go ahead and switch this around, because you remember, I can move that, and then I've got 45 minus 20. Nice and easy. And there we go. Okay, our answer. So notice, I applied the simple rule. Double negatives in this manner becomes positive. I also got nervous with the negative out there, so I moved it around the way I wanted to. Did a little throwback or addition, You got 25 as the resulting answer. All right. And you could apply different other strategies besides this one. This is what I've applied. You may choose whatever strategy works for you. So that will take care of, no, wait, let's continue on. So those type of challenges were on page 113. Continue on from there, some other pages. 111 will be another page where those strategies will work well. And that will be it, okay, when it comes to combining negative and positive integers, all right? That should help you out very well.